Hi, today we're going to learn about assembly modeling. Assembly modeling is where we take a set of components, we mate those together to simulate the behavior we want our design to have. For example, on my screen you see a vise. If I take and rotate the handle, it turns the screw, which in turn causes the slide jaw to move back and forth. That would be an example of an assembly made up of the different components that you see in different colors. And you can see on the left side of the screen these ideas that we're going to call mates, these relations that are associated with the different components. So how do we do that? Well, in SolidWorks there's actually two different ways that we can create assemblies. We can do what's known as bottom-up design or top-down design. Or we can do a combo of those two. Bottom-up design is where we have existing components that we join together and mate, or we associate the different degrees of freedom, that's the technical term, that we want those two components to have. Top-down design is where we start with an assembly, but we don't have the components pre-existing. They haven't already been designed. We don't have those in our folder. We're going to create those in the context of the assembly. Today we'll focus on bottom-up design, and there'll be other lectures on top-down design. So let's start. Let's go to our Moodle page. Go to the topic area called Submit Homework Problems, Textbook Tutorials and Tests. Go down to Tutorial 6. Click on that first file titled Tutorial 6 Component Parts so that you can download that file. Then go to wherever you've located that part and wherever you have it. Right click on it and say Extract All. In my case they're already there, so I'll say extract them again. And we can see that inside that Tutorial 6 folder there's three parts. There's a hatch, a hinge, and a screw. We will use various combinations of these parts to make an assembly of a door. So let's do that. Now open SolidWorks. Go to either File, New, or click the New icon. Up will be a pop-up window. Normally we would click on Part to create a brand new part, but in this case we have our parts. So now we're going to click on Assembly and then OK to tell it we want to build a new assembly in SolidWorks. So we have a blank workspace. On the left side of the screen it says Begin Assembly, and it has some instructions in the message area, one of which says click the Browse button to find the parts that you want, so we'll do that. That's in that folder that we just compressed. We're going to click on Hatch and say Open. And then based on the instructions that are in the yellow box that say if we just click OK, it will insert that hatch into our assembly in such a way that the origins of the hatch itself and the origin of the assembly are aligned. In other words, the coordinate systems of the two will have the same origin. And that's what we want for our first part. So our hatch is our initial component that we're adding to our design. Now let's go and click Insert Components to add additional components to our design. Click the Browse button to go to the folder that has our components. We'll now click Hinge, say Open. It then brings a hinge onto our workspace. We can click near the upper left-hand corner, go back, click Insert Components again, and let's insert another hinge in for our hatch. So click Hinge, say Open. This time put it in the upper right-hand corner. Now let's go and add some of the screws that we need. We can see there's 8 holes here between the 2 hinges. So we can insert 8 components. So if we click Browse, now we want screw, click Open. Now here's a little trick. If we were just to place the screw here now, the screen would disappear, but if we click on the thumbtack, or what the tooltip says, keep visible, now I can just insert multiple sets of these screws. Okay. And now I'll click OK, I'm done. So now I've got all my pieces for my assembly. The next thing is I need to position these pieces in their proper location with respect to the frame itself, or this hatch. I shouldn't call it the frame, it's called the hatch. Alright, so how do I do that? Well, of course I could highlight a part, click Move Component, and I could move it, or I could rotate it, and we have different options over on the left hand side. That's one way to move it. Another way is to right click on the component and go to where it says Move with Triad in the pop-up menu that appears. I like that approach because it's a little faster for me to do things. So I can just sort of slide this part around, because ultimately I want the part to be positioned about here on this one, and I can do the same thing, right click, move with Triad, spin this around. I can then use this arrow and just sort of move it exactly where I want it, or very close to where I want it to be. I shouldn't say exactly where I want it to be, so it's not quite there yet. Notice things like this, as I move it forward, it disappears inside the part. So there's some things that I've got to fix on this. So okay, now let's start creating our mates. And if we look on the left side of the screen, you can see we have now all those, I'm sorry, I'm jumping ahead a little bit. If we look on the left side of the screen, we have the assembly at the top in our feature tree. All the component pieces are shown indented one level so that we can see these are all the pieces that comprise now this thing called ASS EM2 on mine. Yours might say ASS EM1. And then we have a section called Mates that has nothing in it. So let's add some stuff to this area of our feature tree. We do that by clicking on the Assembly tab, going to the Mate button. What it then does is it changes the left side of our screen. We can see we have 4 different sub-tabs under Mates: Standard Mates, Advanced Mates, Mechanical Mates, such as slot, cam, gear, and then we have Analysis as well. Today we're just really going to use the standard mates. Next lecture we might use the standard and advanced and mechanical mates. But today we'll just stick with these basic ones, which are very similar to what you learned with relations when you were doing sketches. Coincident, parallel, concentric. So the terms align very nicely. There's also a distance mate and an angle mate that we can put on our design of our assembly. So I'm going to now use my arrow keys and rotate my part around a little bit, because one of the things I want to do is position these 2 hinges so that this face of a hinge and this face of the assembled hatch are aligned with each other. And you can see that by clicking on each of those, it put those in the mate selection area. And it said, do you want those to be coincident with each other? Yes, I do. I want those to be on the same plane. Now that part has disappeared, but I can slide it back up. I'll do the same with the other component and the hatch. I'll say that. Now we'll see that it's also there, and it's sort of hidden out of my view, so I have to drag it back up. If I go to the top view, it'll be very clear what the behavior is that I've just constrained these pieces to have. Notice they only move right and left, not forward and back. I can't do that because I aligned the faces together with the hatch. The hatch back face with that back face of that hinge. Okay. The next thing I need to do, it's not obvious in that rotation, but I need to make sure that the part doesn't disappear inside, but stays on the top. So how do I make that happen? Well, that's just another mate. And it's going to be another coincident mate. I'm going to take, let's clear those selections. I'm going to take this top face and mate it to the bottom face of that hinge. And I'll say OK. And now if I rotate my part back around, we can see that now it only slides up and down. I'm sorry, left and right, not up and down at all. Where the other one will still go up and down as long as it stays parallel with that back face. Okay, so I'm going to do a similar mating. The top of the hatch, the bottom of the hinge. Make those also coincident. So now we can see in my feature tree I have 4 coincident relations, all that have positioned where I want the hinge to be. Now I just need to prevent it from sliding left and right for both of those. I can do that with a distance mate. And the textbook tells us we want the hinges to be 1 inch from this side of the part of the hatch. So that's easy enough to do. I'll just rotate my part a little bit. I'm going to click in the blue area, click this face, zoom in, click that face, and now I'll say that I want them not to be 1 millimeter, but 1 inch apart. Say OK, and now it's placed that 1 inch away. The fact that it was defaulting to millimeters was my mistake of not setting my units properly. So let's adjust our units to make it inch, pound, seconds. Luckily that doesn't mess up our designs at all because we're not really adding to or modifying sketches yet. We're just positioning where we want our hinges to be. So now we just have to fix this hinge to where we want it to be, which again is 1 inch from this edge, or that, I shouldn't call it an edge, that side of the part. So I'll click, I'm on mates again, I can see that by looking on the left. I click on that face, I click on that face, go down and click the distance mate, and tell it I again want it to be 1 inch. Click OK. And now what have I done? I've created an assembly of a hatch with 2 hinges in proper position. Let's save our design at this point by going to File. Oops, let's get out of mates by saying we're done. Now we can go to File, Save, or Save As. And let's give this a name and we'll call it Door Assembly. Okay, so we call it door, and you'll see that the file extension is not SLDPRT like we're used to seeing. It's now SLDASM. That's because we have an assembly, which is a different file extension. Click the save, and in our next video, we'll insert these screws into their appropriate locations and add pilot holes to the wood hatch to help